This is the Edexcel higher tier paper one from November 2021. It's a non-calculator paper. So let's get started. Question 1. Work out 3.67 times 4.2. When we're multiplying decimals, we can take the decimals out of the question and put them back in at the end. So we can work out 367 times 42. And there's lots of methods you can use for that. I'm going to use the column method. So I'm going to write 367 times, and lining them up, 42. So multiplying by 2 first. So 2 sevens are 14. 2 sixes are 12, plus 1 is 13. And 2 threes are 6, plus 1 is 7. Now I'm going to multiply by 40, the 4. Because I'm multiplying by 40, not 4, I'm going to add a 0. 4 sevens are 28. So carrying the 2 over. 4 sixes are 24, plus the 2 is 26. And 4 threes are 12, plus the 2 is 14. So then adding these two multiplications together in columns, so 4 and 0 is 4. 8 and 3 make 11. 7 and 6 and 1 is 14. 4 and 1 is 5. And in the 10,000s, we've just got a 1. So that's 1. So 367 times 42 is 15,414. But we wanted 3.67 times 4.2. So we just look at how many decimal places there are in the question, how many numbers are after the decimal places. So 1, 2, 3 numbers after the decimal places in the question. So we want 1, 2, 3 numbers after the decimal place in the answer. So we've got 15.414. So to get from 3.67 times 4.2 to change that question to 367 times 42, we've got to times by 10, 1, 2, 3 times. So to undo that, we divide by 10 3 times. So there's our answer, 15.414. Part B, work out 59.84 divided by 1.6. I'm going to change the question. So at the moment we've got 59.84 divided by 1.6. I'm going to change the 1.6 to a 16. And I'll do that by timesing the top and the bottom by 10. So 598.4 divided by 16. Now these are equivalent fractions. They're exactly the same. So if I divide 598.4 by 16, that's the same answer as dividing 59.84 by 1.6. They're identical. So I won't have to do anything to the answer this time. And I'm going to use the bus stop, use the long division or short division method. So 16 into 598.4. It might be useful to write our 16 times table down. That's quite a difficult one. So 16, double it, 32, add on another 16 for 48. Then add on another 16, will be 64. 5 times 16 now, that's 80. 6 will be 96. One more 16, so add on 4 to get to 100. And then 12 more, so 112. That's 7 16s, 8 16s is double 4 16s, so 128. 9 16s, so one more 16 on here. So add 12 to get to 140, and then 4 more. And 10 16s is 160. So that should make it a lot easier. So let's do the division now. How many times does 16 go into 5? Well, none. So carry the 5 over. How many times does 16 go into 59? 1, 2, 3 times. And that's 48. So we need another 11 left over. So that's 118 now. How many times does 16 go into 118? 1, 2, 3, 4, 5, 6, 7 times, which is 112. So 6 left over. And how many 16s go into 64? That's 4. So we've got 37.4. Question 2. So we've got our universal set, everything, is the even numbers less than 19. So let's write them down. So all the even numbers that are less than 19, that's 2, 4, 6, 8, 10, 12, 14, 16, and 18. Then in the A circle, we want 6, 12, and 18. And in our B circle, 2, 6, 14, and 18. And the question says complete the Venn diagram. So what's in both circles? We've both got a 6. 6 is in both circles. And 18 in both circles. Then in the A circle is just 12. So 12's gone. In the B circle, we've got 2 and 14. So that's 2 and 14. So we've crossed off 5 of our numbers. All the ones that are left go on the outside. They're not in the A circle, and they're not in the B circle. So we've got 4, 8, 10, and 16. 4, 8, 10, and 16. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know we've got all of them. Question 3. Work out 4 and 1/5. Take away 2 and 2/3. Give your answer as a mixed number. The first thing we need to do is to change these from mixed numbers into top-heavy fractions, improper fractions. So if we've got 4 and 1/5, 4 whole ones is 4 times 5, 20/5. So 4 is the same as 20/5. And we've got 20/5 and 1/5, which means we've got 21/5. 2 whole ones in thirds is 2 times 3. So 2 is the same as 6 thirds. And we've got 6 thirds and another 2 thirds, which means we've got 6 and 2, 8 thirds. So we've got 21/5. Take away 8 thirds. To add or subtract fractions, we need the denominator to be the same. We need the bottom number of both the fractions to be the same. So if we times our 21/5 top and bottom by 3, so we're timesing the top and bottom of 21/5 by 3, and we're timesing the top and bottom of 8 thirds by 5. And that will give us a common denominator. It would mean both denominators are 15. So 3 times 21 is 63. 3 5s are 15. 5 8s are 40. And 3 5s are 15. So we've got 63 fifteenths, take away 40 fifteenths. 63 of something, take away 40 of something, gives us 23 of that something. So 23 fifteenths. We wanted our answer as a mixed number. So how many whole ones do we have? If we're in 15ths, we've got one whole one. That's 15 15ths. And then how many more? 15 plus what makes 23? That's 8. So one whole one and 8 15ths. Question 4. At the end of 2017, the value of Tamara's house was 220,000. The value of Rahim's house was 160,000. At the end of 2019, the value of Tamara's house decreased by 20%, and the value of Rahim's house increased by 30%. At the end of 2019, whose house had the greater value? And you must show all of your working. So we need to take away 20% from Tamara's house. So for Tamara's house, 100% is 220,000. So 10%, we can work out 10% by dividing by 10. So that's 22,000. And that would be 10%. We want to take away 20%. So two of those, two 10% make 20%. So that's 44,000. And that's 20%. So we need to take that off. It's decreased by 20%. That means it's decreased by £44,000. So 220,000 take away 44,000. If we take away 40,000, we would get to 180,000, and then take away another 4, that's 176. So that'd be £176,000. How about Rahim's? So it started off at 160,000, and we want to add on 30%. So to find 10%, divide by 10, that's 16,000. To find 30%, times that by 3. So 3 16s are 48. So 3 16,000s are 48,000. So that's 30%. We need to add that on, so it's increasing. Add it on. 160,000 plus 48,000. So that gives us 208,000. So whose house is worth more? Well, that's Rahim's house. Question 5. Rosie, Matilda and Ibrahim collect stickers. The number of stickers Rosie has to the number of stickers Matilda has to the number of stickers Ibrahim has is 4 to 7 to 15. Ibrahim has 24 more than Matilda. So that's Ibrahim, Matilda, Rosie. Ibrahim has 24 more. How many more stickers does he have than Rosie? So each of these parts is worth the same. So Rosie's got 4 parts, Matilda's got 7 parts, and Ibrahim's got 15 parts. Ibrahim's got 24 more than Matilda, and that's 8 parts more. So Matilda's got 7, Ibrahim's got 15, so he's got 8 more. So 8 parts more. And those 8 parts are worth 24 stickers. So 24 stickers must be 8 parts. So if we divide 24 by 8, we get 3. So each part is 3 stickers. So each part is 3 stickers. So Rosie's got 4 3s. So Rosie has 12, 4 times 3. Matilda's got 7 3s, 21. And Ibrahim's got 15 3s, which is 45. So we can see Ibrahim has got 24 more than Matilda. How many more does he have than Rosie? So 45, take away 12, is 33. Question 6. The diagram shows a prism. The cross-section of the prism is a right-angled triangle, which we can see here. The base of the triangle is 5, we can see that. The length is 25 of the prism, again that's on the diagram. And the volume of the prism is 750 centimeters cubed. So we need to work out the height. So volume of a prism is the area of the cross section, which in this case is the triangle at the front. Area of the cross section times the length, which is 25 times length. The area of a triangle is half times base times height. Half base times height. So half times base times height. So 5 times height times the length, which is 25. And that volume is 750. So 750 is half times 5 times the height. That's the area of the cross section times the length of the prism. So let's work this out. So we'll do 5 25s are 125, and half of that, half of 125, it doesn't go exactly, so I'm going to write it as 125 over 2. So that's half times 5 times 25, and that's times the h. So I'm not going to write the times sign, I'm just going to write h. So we're solving for h, so I'm going to get rid of the fraction. To get rid of a divide by 2, I do the opposite of dividing by 2. So I'm going to times both sides by 2. 2 750s will be 1,500, and that equals 125h. So to get h by itself, at the moment it's times by 125. To do the opposite of timesing, I divide. So divide both sides by 125. So I need to simplify this, or I'm going to simplify this, and I'm going to double the top and the bottom. So if I double the top and the bottom, that will get me 3,000 over 250. Then I can divide top and bottom by 10. And then how many 25s go into 300? There are 4 25s in 100. So 4, 4 and 4 again. That gives me 12. So it's 12, and it's centimeters. So the height of the triangle is 12 centimeters. Question 7. The diagram shows a cube with edges length x centimeters and a sphere of radius 3 centimeters. We're told the surface area of the cube is equal to the surface area of the sphere, and show that x equals the square root of k pi, where k is an integer, a whole number. So the surface area of a cube Well, it's the area of all the surfaces added together. So each length is x centimeters. So each surface is x times x. That's x squared. And how many surfaces does the cube have? So the front, the back, the top, the bottom, the side, that's 6 surfaces. So 6 x squareds. So that's 6x squared. That's the surface area of the cube. The surface area of a sphere, the formula is given to us. So it's 4 pi r squared. So 4 pi, r is 3. So 4 pi times 3 squared. 3 squared is 9. And 9 times 4 is 36. So we've got 6x squared equals 36 pi. Divide both sides by 6. So 36 over 6 is 6. So x squared is 6 pi. To get x by itself, the opposite of squaring is square rooting. So x is the square root of 6 pi. And that is in the form we wanted it. So that's our answer. Question 8. Solve x squared equals 5x plus 24. This is a quadratic. The highest power in this equation is a squared, an x squared. So we know we've got a quadratic, and we solve quadratics by making them equal to 0. So I'm going to take away 5x from both sides. So x squared minus 5x equals 24. And then take away 24 from both sides to make it equal to 0. So x squared minus 5x minus 24 equals 0. The easiest way to solve a quadratic is usually factorizing. So to factorize it, we're going to have double brackets. We're going to have an x in each of them. And we're looking for two numbers that multiply to give a negative 24 and add or subtract to give us a negative 5. So it can help to list the factors of 24. So 1 24, 2 12s, 3 8s, or 4 6s. Which of those can give me a 5 or a negative 5? 3 plus 3 minus 8. That will give us a negative 5. So plus 3 minus 8. Then to solve it, we're looking at what makes the brackets 0. So what does x have to be for this first bracket to be 0? That's negative 3. Negative 3 plus 3 is nothing. And for the second bracket to be 0, x would have to be a positive 8. So x can be negative 3 or positive 8. Question 9. Write down the value of 7 to the power of 0. Anything to the power of 0 is 1. Part B. Find the value of 3 times 3 to the power of 6 times 3 to the power of negative 6. So when we multiply indices, we add the powers. So 3 by itself is 3 to the power of 1. So we're going to have 1 plus 6 for the powers, and then plus minus 6. Plus minus just means minus. So 3 to the power of 1 plus 6 minus 6. 1 plus 6 is 7. Take away 6 is 1. So it's just 3 to the power of 1, or 3. Part C. Find the value of 2 to the power of negative 4. 2 to the power of negative 4. When we've got a minus in the power, it flips it. So 2 to the power of negative 4 is the same as 1 over 2 to the power of 4. 2 to the power of 4 means 2 times 2 times 2 times 2. So that's 16. So it's 1/16. Part D, find the value of 27 to the power of a third. The power of a third is the same as a cube root. So power of a half is a square root, power of a third is a cube root. So the cube root of 27 is 3. 3 times 3 times 3 makes 27. So the cube root of 27 is 3. Question 10. The diagram shows a shape made from 6 identical squares. The total area of the shape is 5,406 centimeters squared. Find an estimate for the length of one side of each square. So it's an estimate. That means we don't have to use the exact numbers. So we can say it's 5,400 for the total area. If we divide that by 6, we know 54 over 6 is 9. So each will have an area of 900. So each square would have an area of 900 centimeters squared. To find the length of each side, we need to square root the area. So the square root of 900. If you're not sure, we can change that to square root of 9 times square root of 100, which is 3 times 10, which is 30. So give your answer correctly, nearest whole number, 30 centimeters. Is it an underestimate or an overestimate? So what did we do? We rounded down. We rounded the total area down. So the area would have been slightly bigger, which means we would have got a slightly bigger answer. So it's an underestimate. An underestimate because we rounded the total area down. Question 11. The diagram shows 2 rectangles A and B, all measurements in centimeters. The area of A equals the area of B. Find an expression for Y in terms of W. So area of A equals area of B. So area of A, so the area of a rectangle is length times width. So area of A is 6 times 2W plus Y. Area of B is 7W times 3Y plus 6. We want Y by itself, so we want to make Y the subject of the formula now. So let's expand the brackets and get all the Y's over to the same side. So 6 times 2W will be 12W, and 6 times Y is just 6Y. 7W times 3Y, 7 3s are 21, and then we've got times W times Y. 7 6s are 42, and it's 7W times 6, so it's 42W. So we've got 2 terms with a Y in it, so these 2 terms. We want them on the same side, and everything else on the other side. So we can take 12W away from both sides. So 6Y equals 21YW. If we take away 12, 42, take away 12 is 30. So 30W. I'm going to take away 21YW. 21WY. Take that away from both sides to get the Y terms together. And then the only way I can get one Y, just a y by itself is to factorize. So I'm going to factorize out a y. So y times 6 is 6y. Y times 21w is 21wy. So now I can get y by itself by dividing both sides by 6 minus 21w. So we've got 30w over 6 minus 21w. So now y is by itself, and that is our answer. Question 12. So the cumulative frequency table gives information about the heights in centimeters of 40 plants. And we need to draw a cumulative frequency graph. So we're going to be plotting the top point against the cumulative frequency. So 5 against 4. 5, 4. 10, 11. 15, 24. 20, 34. 25, 38. And 30, 40. So we need to join them up. We can use a smooth curve or we can use straight lines. I'm going to use straight lines just because it's quite difficult to draw a smooth curve on the computer. So that is our cumulative frequency graph. Use the graph to find an estimate for the median height of the plants. So there are 40 plants. There are 40 plants. The middle number, halfway, we're going to look for 20, the 20th plant. So on our cumulative frequency, we go to 20, along to our line, and then down. So we should get an answer somewhere around. So that is 13.5, because we're going up in twos here. So 11, 12, 13, 14. So I've got 13.5. You might get something slightly different because it will depend on your graph. But 13.5 is what I will write here. Question 13. Ted is trying to change 0.43 recurring, so 0.434343 to a fraction. Here's his method. So x is our number. 10x is 4.34 recurring. So 10x take away x is 4.34 recurring minus 0.43 recurring. Evaluate Ted's method. So Ted's method isn't very good because he hasn't got two things ending in 43 recurring. So when we're changing a recurring decimal to a fraction, we want to get two things ending in the same recurring number. So to get something else ending in 43 recurring, we would have to times by 100 to get 43.43 recurring. So we can take them away, so we can get rid of them. So Ted should have found 100x, not 10x. It's only one mark, so that should do. Question 14. Here is a shape with all its measurements in centimeters. The area is a centimeter squared. Show that, so find the area. Show that a is this. So we should get, for the area, 2x squared plus 24x minus 46. So we're going to split this into two shapes. So doesn't matter which way we split, we could split this way or this way. We'll get the same answer either way. And then we just need to find the missing. So the whole height is x plus 11. This bit here that we've cut off is 4. So we take 4 away from x plus 11, gives us x plus 7. So x plus 7 plus 4 is the same as x plus 11. So then we'll find the area. So it's the area of one rectangle plus the area of the other rectangle. So we've got 4 times x plus 1, and we've got 2x plus 6 times x plus 7. So we'll expand all of these brackets. 4 x's are 4x, 4 1's are 4. 2x times x is 2x squared. 2x times 7 is 14x. 6 x's make 6x, and 6 7's 42. Then collecting all of the like terms, so we've only got one x squared term, so that's 2x squared. The x terms, we've got 4 plus 14 plus 6, that makes 24x, and we've got 4 and 42, which makes our 46. So there is our answer. We've shown that that is the answer. Question 15. Show that 4x plus 3 over 2x plus 3/5 can be written in the form ax plus b over cx, where a, b, and c are integers. So we're just adding these fractions together, and we should get something that looks like this, but a, b, and c will be numbers. So to add fractions, we need a common denominator. So we need to make the denominators the same. We can do that by timesing the top and bottom of our left fraction by 5, and top and bottom of the right fraction by 2x. That will make both denominators 10x. So 5 times 4x plus 3. I'll write that as brackets. 5 times 4x plus 3 over 5 times 2x, which is 10x. 3 times 2x is 6x. 5 times 2x is 10x. So now we've got our common denominator, so we can add the fractions. So we're going to have 5 times 4x plus 3 plus 6x all over 10x. So all we need to do is expand and simplify the top line. So 5 times 4x is 20x. 5 3's are 15. And then we've got plus 6x over 10x. And to finish, we just need to add 20x and 6x. So 26x plus 15 over 10x. And that is in the form we wanted it. Question 16. There are only 3 red counters and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red counter. So we could do this with a probability tree. We could have red, yellow for the first pick, red or yellow for the second pick, and red or yellow for the third pick. So we could draw out a probability tree with 3 picks, or we could go straight to listing the combinations that will give us 1 red counter. So we can either get red, then yellow, or yellow, then red, then yellow, or yellow, then red. So there's only 3 combinations where we get 1 red counter, and we could work out the probabilities of each of these. So the probability of red, then yellow, So there are 3 red and 5 yellow to start with. The chance of getting a red is 3 out of 8 for the first pick. Then when we've taken a red out, there are now 2 reds and 5 yellows. So the chance of getting a yellow for the second pick will be 5 out of 7, because 1 red counter has gone. Then for our third pick, we've now taken out a red and a yellow already. So the chance of getting a yellow, there are now 4 yellows out of 6 in total. The probability of getting yellow, red, yellow. So the yellow, the first pick, will be 5/8. Then if we've taken a yellow out, there are still 3 reds in out of 7 in total. And if we've taken 1 red and 1 yellow out, there are 4 yellows left out of 6 in total. And finally, yellow, red. That will be 5/8 times 4/7 times 3/6. And you'll notice that each of these are the same. So the numerator is always 5 times 4 times 3 in one order or another. And the denominator is always 8 times 7 times 6. So we need to multiply these fractions. When we multiply fractions, we multiply the numerators together and multiply the denominators together. It would be easier if we simplified first. So if we divide top and bottom, so remember the top of the fraction is 3 times 5 times 4, and the bottom is 8 times 7 times 6. So if we divide top and bottom by 4, and top and bottom by 3, we should be left with something easier to multiply. So 1 times 5 times 1 is 5. 2 times 7 times 2 is 28. So that's 5/28. And because they're all the same, they're all going to be 5/28. So the probability of getting 1 red would be this one, or this one, or this one, which means we add them together. 5/28 plus 5/28 plus another 5/28 will be 15/28. So that's the probability of getting 1 red counter. Question 17. On the grid, show by shading the region that satisfies all of these inequalities. So we need to draw these lines. We're going to label the region R once we've done it. So the region that satisfies all the inequalities. We're going to start by drawing the lines. So we've got 2y plus 4. We're going to draw the line 2y plus 4 equals x. I think we will rearrange it to make it y equals. So 2y equals x minus 4, and then half it. So y equals half of x minus 2. So we've got a gradient of a half, and its y-intercepts at -2. So the y-intercepts at -2, and its gradient is 1/2. So for every 1 it goes across, it goes up half. Across 1, up half. Across 1, up half, across 1, up half, and so on. So we're going to draw the line. I'm going to draw a full line in for now, but because it's not or equal to, it's not an or equals to, we're supposed to have a dotted line. So we don't want this whole line. We want a dotted line. So we need to change this somehow into a dotted line. There we go. So that's our first line. Then we've got x is less than 3. So we'll draw x equals 3. So all the points where x equal 3, x equals 3 here, 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 and so on. So that's our straight line. And again, we want a dotted line because it's not x is less than or equal to 3, it's just less than. And our other graph, we want y equals minus 3x plus 6. So it's got a y-intercept of 6, which is up here, and a gradient of minus 3. So across 1, down 3. Across 1, down 3. Across 1, down 3, and so on. So we'll draw this line. And again, we want a dotted line. That one's probably nicer. So we'll have a dotted line for each of them because none of them are or equal to. So we don't actually want y equals half x minus 2. It's actually y is less than half x minus 2. We want x is less than 3 and y is less than minus 3x plus 6. So that means y is less than, y is underneath. We want below the lines. So that's down for this one, and x is less than 3. That's to the left. So where is this region? So below both the lines, and to the left of this one, this is our region over here. And we can check that with a coordinate. So let's pick a point in here. So let's say 0, minus 5. So this point here, 0, minus 5, should satisfy all of the inequalities. 0, minus 5. Let's see if it works. So when x is 0, y is minus 5, all of these should work. 2 minus 5s make minus 10, plus 4 is minus 6, minus 6 is less than 0, so that's true. 0 is less than 3, that's true. And we've got minus 5 is less than 6, take away nothing, so minus 5 is less than 6, and that's true. So we know we've got the right region, and that's the one down here. Question 18. Here is a trapezium, ABCD. The area of the trapezium is 66 centimeters squared. We are told the length of AB to the length of CD is 2 to 3. So we could call them 2x and 3x. So AB is 2x, C to D is 3x. we need to find the length of AB. So we're going to have to use this information we're given, the area. So area of a trapezium is half the sum of the parallel sides. That will be our 2x and 3x times the perpendicular height times the distance between them. Now we don't know the perpendicular height, but on the diagram we've been given a diagonal and an angle. So we can make a right-angled triangle here and find the perpendicular height to substitute in to the area formula. So let's do that. We've got the hypotenuse and we want to work out the opposite. So we're not interested in the adjacent. So it's going to be sine, so sine with the angle 30, sine 30 is O over H. I'm going to call it Y for now. So Y over H, which is 6. So Y is 6 times sine 30. Sine 30 is a half. So 6 halves are 3. So Y is 3. Our perpendicular height is 3. So now we can use our area. The area is 66, and that's equal to half the sum of the parallel sides, so 2x plus 3x, which is 5x, times the perpendicular height, 3. So solving this equation, divide both sides by 3. 22 is half of 5x. Double both sides. 44 is 5x. So x is 44 fifths. 44 over 5, which doubling top and bottom is 88 over 10, or 8.8 centimeters. We want the length of AB. We don't want x. We want 2x. So 2x, 2 of these, 2 8.8s. So 2 8s are 16. 2 0.8s are 1.6. So we've got 17.6 centimeters. Question 19. Show that 8 plus root 12 over 5 plus root 3 can be written in the form a plus root 3 over b, where a and b are integers. So that means we're rationalizing the denominator. We're getting rid of the irrational number, the third, from the denominator. I'm going to start by changing root 12. I'll do that first. So I can simplify root 12, because root 12 is the same as root 4 times root 3, which is 2 root 3. So 4 3s are 12. So root 4 times root 3 is root 12. And square root 4 is 2. So that's 2 root 3. So 8 plus 2 root 3 over 5 plus root 3. So when we've got a number and a third on the bottom, we rationalize the denominator by multiplying by the same thing but changing the sign. So 5 plus root 3, we want to times it by 5 minus root 3. And because we're doing that to the bottom of the fraction, we need to do that to the top as well. So when we expand these brackets, the square root sign, the root 3 should disappear from the denominator. So let's give it a go. So let's do the numerator first. 8 5s are 40. Positive times a negative is negative. 8 times root 3 is 8 root 3. 2 root 3 times 5 is 10 root 3. And a positive times a negative is negative. 2 root 3 times root 3 So 2 root 3 times root 3. Root 3 times root 3 is 3, and 2 3s are 6. Now the denominator, 5 5s are 25. Positive times negative is negative. 5 root 3s are 5 root 3. 5 root 3s are 5 root 3. And root 3 times minus root 3 will be minus 3. So simplifying this, so on the top for our numbers, we've got 40 take away 6. That's 34. We've got 10 root 3s take away 8 root 3s, which is 2 root 3s. And on the bottom, 25 take away 3 is 22. And minus 5 root 3 plus 5 root 3, they cancel out. That's why we did the same bracket, but changed the sign. We did it so the middle numbers cancel out. We can do one more thing to simplify this. We can divide everything by 2, half the top and half the bottom. So that's 17 plus root 3 over 11. And that is in the form we were asked to put it in. Question 20. So here we've got a circle. X squared plus y squared is 30.25. Find estimates for the solutions of the simultaneous equations. So we've got the circle that's drawn for us, and y, if we add 2x to both sides, y equals 2x plus 1. When we're solving simultaneous equations on the graph, the solutions are where the two graphs intersect. So if we draw the line, y equals 2x plus 1. So it's got a y-intercept of 1 and a gradient of 2. So across 1 up 2, across 1 up 2, and so on. Back 1, down 2. So let's join these up. So a straight line through these points. And where does it intersect? Let's just extend this line a little bit. So what are the solutions? The solutions are where the graphs intersect. So it's at this point here, which seems to be at 2, 5.2. So x is 2, y is 5.2, or the other intersection is here, which is at minus 2.8 minus 4.8 minus 2.8 minus 4.8. So x equals minus 2.8, y equals minus 4.8. So the solutions to simultaneous equations on a graph are where the two graphs intersect. Question 21. The functions f and g are such that f of x is 3x squared plus 1, and g of x is 4 over x squared. Work out gf of 1. So when it's gf of 1, that means we're putting 1 into f. So gf of 1, we're putting 1 into f, and then we're putting that answer into g. So f of 1 is 3 times 1 squared plus 1. 1 squared is 1, so 3 ones are 3, plus 1 is 4. And we're putting that answer into g. So g of 4 is 4 over 4 squared, which is 4 over 16, or just a quarter simplified. the function h is the inverse of fg. So fg minus 1. The inverse function of fg. So that's the inverse function is the function that goes backwards, the opposite function. So let's work out what fgx is first. So fgx means we're putting the g function into the f function. So the g function goes into the f function. So f of 4 over x squared is 3 times 4 over x squared squared plus 1. So that's 3 times 16 over x to the power of 4 plus 1, which is 3 16s are 48. So 48 over x to the power of 4 plus 1. So that's our function fg of x. So what's the opposite to this? What's the function that would go backwards to this? So what we could do, one way of doing it, is to say if y equals this, what would happen if I make x the subject of the formula? So how do I get x by itself? How do I undo this function? So I will take 1 away from both sides. Y minus 1 is 48 over x to the power of 4. Then I'm going to times by x to the power of 4. Times both sides by x to the power of 4. And then divide by y minus 1. So 48 over y minus 1. And then to get x by itself, I'll do the fourth root of 48 over y minus 1. So that's the function that undoes it. That's the backwards function. So if I write h of x will be the fourth root of 48 over x minus 1. So for the inverse function, we're switching the input and the output around. So the x becomes the y becomes the x. Question 22. Find the coordinates of the turning point on the curve with equation y equals 9 plus 18x minus 3x squared. So to find the turning point, we're completing the square. I'm going to write this with the x squared term first. So minus 3x squared, then the x term, and then the number. Now I'm going to factorize out this coefficient of x squared. So the number in front of the x squared, which is minus 3. So I'm going to take minus 3 outside the bracket. I want to get rid of it. So I've got minus 3 times x squared to give me minus 3x squared. Then minus 3 times minus 6x will give me 18x. And minus 3 times minus 3 will give me a positive 9. So now I can complete the square on the bit inside the bracket. So I'm keeping the minus 3 outside. I'm going to write a big bracket, and then I'm going to complete the square. So to complete the square, we halve the middle number. So half the b number, which is negative 6. Half of negative 6 is minus 3. So we've got x minus 3. That's going to be squared. And I'm going to take away 3 squared, which is 9. And I've still got the minus 3 on the end. So I've got minus 3 times x minus 3 squared minus 12. So I've completed the square. I'm going to expand this big bracket. We don't have to, but I think it'll make it clearer. So minus 3 times x minus 3 squared, and then minus 3 times minus 12 is a positive 36. So the minimum point, the turning point even, the turning point of this graph is going to be, the x is going to be whatever makes this bracket 0. That's going to be when x is 3. And when that's 0, so this will be 0, 0 squared times minus 3 is 0. What's left? 36. So y will be 36.